Well, the phones won't stop ringing, or they don't ring at all. Contact center agents waste time answering bogus calls while customers complain they can't get through. 911 agents waste time answering robocallers instead of dealing with real emergencies. Telephony Denial of Service, or TDOS, attacks clog up business telephone lines, causing disruption of business and wasting employee productivity. TDOS attacks be the result of nefarious actors trying to extort money or a targeted grudge to settle, but also can come from rogue robocall campaigns. Either way, TDOS attacks are becoming more common and more difficult to prevent. Service providers are often unprepared and unable to address TDOS attacks, leaving businesses vulnerable while they search for a solution. Welcome to How to Protect Against TDOS Attacks, our 22nd monthly webinar in the free SBC Pro SBC series, covering technical, business, and partner topics to help service providers and enterprises better secure the networks. During today's session, we describe the methods that service providers and businesses can use to mitigate TDOS attacks, reducing or eliminating their impact. Towards the end of the session, we'll also share 3 real end customer case studies showing how these businesses implemented their own TDOS solutions, deflecting hundreds of unwanted calls per day. So let's get started. All right, so we've got quite a bit on our agenda today. I wanted to share with you, first of all, we're going to go through a couple of introductions, and then we'll talk about the TDOS problem, where it comes from, and sort of the source, so that you can understand better how it can be mitigated. And then we'll talk about mediation, how to resolve some of the SIP and TDM mediation, how to detect them, and some case studies, and then we'll end up with some Q&A. All right, let's start out with some introductions. I'm Alan Percy. I'm the Chief Marketing Officer for TelcoBridges and covering the software products and today's event moderator. We're joining us again today by Jim Dalton. He's the CEO of TransNexus, along with Alec Finichel. He's a software engineer at TransNexus. And gentlemen, thanks so much for your contribution and helping out again today.
Thank you, happy to be here.
Yep.
Thanks, Alan.
You bet. All right, let's start out just a little bit of introductions. I looked again at the registration list. We have lots of new faces on the list. And I just want to give a quick overview of who TelcoBridges is. We're a manufacturer of telecom VoIP gateways and SBC software, privately held. We were founded in 2002 with about 40 employees based in Montreal. We do most of our development, software development and hardware development there in the offices in Montreal. And we've got sales and support offices in Poland, Turkey, Hong Kong, where we provide 24/7 technical support for the gateways and SBCs and other products. So it's a quick overview of that. And with that, I'm going to turn it to Jim to just give a quick overview of TransNexus.
Thanks, Alan. TransNexus, our focus since 1997 has really been on routing and policy solutions for voice over IP networks. And most of our customers use our platform for least cost routing, but that same least cost routing dip is a great opportunity for toll fraud protection and also for inbound calls, analyzing the calls coming in and filtering out robocalls and stopping TDOS attacks. So that's our focus of our business.
Great, and you're based in Atlanta, and that's great. Awesome. All right, so I wanted to start the discussion with a little bit of a story, and some of you may have seen this. Was an article published in Network World a few years ago, and the title of the article is "The Day That the 911 Network Stood Still." And this was a hacker in the Phoenix area who was basically probing Apple iPhone security, looking for holes in its security. And he created this little web application that would dial 911 if someone were to activate it. And of course, he posted the application online via Twitter. And it turns out that 1,800 people in the Phoenix area compromised their phones and then flooded the 911 network center with calls so overwhelmed that the PSAP was unable to answer any actual live calls. And for well over a day, this entire geographic area was without 911 service, which, as you can imagine, is a serious problem. You know, the ambulances, police, fire, everything came to a screeching halt. And it was a very difficult denial of service attack to stop, because they actually had to do a power cycle on the user's phones to get this thing to stop. And I've included a link to the full article here at the bottom of the slide. So when you get the slides afterwards, you might want to read that. It's a very sobering article about a situation. And this is just one example. And this example was the foundation for some work that the Department of Homeland Security initiated. William Bryan, the senior official performing the duties of the Undersecretary of Science and Technology, that's a mouthful, noted here, if coordinated with an actual physical terrorist attack, this style attack would be particularly catastrophic, resulting in a large number of victims losing the ability to connect with emergency services. So the thinking is, you know, if there were some physical actual attack by a terrorist, you know, an example is some of the, you know, 9/11 attacks, if they prior to that clogged the 911 system, it could cause a significantly larger loss of life and property damage. So it's a genuine concern that the Department of Homeland Security is taking very, very seriously. So, you know, looking a little bit deeper at TDOS, you know, I think it was for a long, long time, it was just kind of a nuisance, right? The robocalls and some of this stuff was just a nuisance. But I think we're now starting to realize it's really starting to have a negative impact on not only businesses and government and some particularly vulnerable businesses, you know, like we just mentioned, the 911 emergency call centers, but also, you know, banking and financial, healthcare and contact centers seem to be particularly vulnerable to these. Really throwing a monkey wrench into the works. And we'll get into some of these case studies towards the end of the session. You'll see how these individual businesses are struggling with them and some methods that they can use to rectify it. One of the things that to me was a little bit sobering as I started to research this topic and get a little bit closer to it, is it really turns out there's just two attack profiles. One of them is a tsunami of traffic, right? This is just somebody generates so much telephone traffic to a particular target, they just overwhelm the telephone facilities, whether they overwhelm the trunk ports or they overwhelm their PBX or they overwhelm their UC platform, whatever it might be, but it's just a huge amount of traffic. And those do exist. We do see those tsunami of traffic kind of attacks. But what seems to be pretty common too is I've named it the persistent pest. And this is the dripping faucet problem. It's just constant, nonstop, low volume of calls that are taxing to people and resources inside the organization. They don't necessarily clog up the whole system, but they clog up enough of it to be, you know, costly in a difficult problem to solve. So when we get into the case studies, we'll talk about, there's actually a couple of different scenarios when we get to the end. So where do these things come from? Well, one of the unfortunate side effects of all this really nifty VoIP technology is that we've made it faster, cheaper, and easier to hide the origin of calls. And unfortunately, this is one of the negative side effects, is this, you know, these TDOS attacks. They're actually relatively easy now to get a set of SIP trunks, for example, to create quite a bit of traffic. The attacks that often are also distributed, meaning, you know, they distribute malware that goes onto desktops or to mobile devices, and the users of those devices don't realize it, but those devices have become, you know, Trojan horses, and they're part of a distributed attack. You know, at midnight on a certain day, they all wake up and suddenly, you know, dial a phone, and that creates a tsunami of traffic to a particular target. We've also discovered that some of the popular open source platforms are very, very easy to create applications that can generate a large volume of calls, and not only just generate the call, but also stimulate or manipulate the IVR or ACD that's at the other end to create, you know, loops that would allow the call to stay up and tie up the port for a longer period of time. some of the new CPaaS platforms, the communication platform as a service, are initially they were susceptible to being used for this kind of application. Fortunately, most of the big ones have now put call rate limiters within their platform. But there was a long, long time when it was very, very easy with CPaaS to create a TDOS attack, to play prompts, to get to detect when people answer, and keep them busy with a series of prompts to tie up the phone line. And lastly, some of the legitimate notification services, right? There's services designed to do reverse 911, to do school closing applications. These kinds of things could be very easily used for nefarious purposes to generate a TDOS attack. So a handful of places, and honestly, no single TDOS attack is alike, to each other. They seem to be all very much customized based on their target. So what are some of the motivations? And we've kind of looked at many of the case studies and narrowed it down to a handful of motivations. One of them is extortion. This is relatively rare, but which was one of the more severe ones, which is the old send me $10,000 in Bitcoin or else I'm going to, crush your contact center. You don't believe me? I'm going to do it at 10 o'clock tomorrow. Boom, they crush it. And then they say, okay, send the $10,000 and I'm going to do it to you all day tomorrow. And of course a contact center or bank or one of these, they might fold and pay the money. There's a distraction motivation too, which is I'm going to tie your resources up, and while you're trying to chase this, I'm going to go hack your system. And it's kind of a, the old magician distraction methodology of look over here, and while you're doing that, I'm going to go invade your systems. Frankly, there's a lot of pranksters out there too. They're just looking for fame and fortune. And we've seen reports of some of the online forums. These guys brag about their bravado about being able to go in and make a mess of some target. We talked about the robocalls, the inadvertent TDOS, right? A robocall platform that maybe doesn't advance to the next number like it's supposed to, just hammers the same number over and over and over again, or a database gets polluted with a lot of duplicate numbers, might inadvertently hammer on a particular business. And when we get to our case studies, we'll see one of them is that. And the last is going after a competitor. And one of our stories towards the end is exactly this. This is where a competitor is creating traffic to one of their competitors, tying up their phone lines and wasting their agent's time in a way to deflect business over to them. So what's the impact on some of these different businesses? Well, of course, doctors and healthcare workers, they have to answer the call, right? I could see one of our EMS participants here talking about it, but you got to answer the calls. The 911 operators have to answer the calls. Contact center people, the phone rings, they answer it, right? They, if the ECD sends them a call, they answer it, and it wastes time. As a matter of fact, one of our customers analyzed the number of minutes that each agent had to waste dealing with these robocalls that were coming into their platform, and did the math, and it was a frighteningly large amount of personal time money that was being wasted by the agents. Businesses have, if they have all these calls coming in, they can't get to the good ones, right? It's hard to sort them out. Imagine being a plumber today and having to answer your cell phone every time it rings. When half of them are bad calls. And then, of course, consumers hate it, and they complain to their service providers, and frankly, they complain to each other too about the robocalls that pester them. So let's take a look at an architecture diagram and get a little bit closer to understanding a methodology to resolve this. And this, what we're showing here, is a typical enterprise deployed hosted or enterprise deployed PBX. It could be hosted, meaning this SBC and the PBX could be on the cloud. The phones obviously would be in the customer premise, or it could all be on-prem, right? The SIP trunking could land at the customer's SBC. The PBX could be in-house. And so there's any one of those. But kind of stepping through here real quick, if someone initiates a TDOS attack, one of these hackers starts generating a large volume of calls over a VoIP infrastructure, it's going to all land on the SIP trunk. The SIP trunk's going to send it to the SBC. The session border controller by itself does have some ability to thin this traffic down based on frequency and where the calls are coming from, but otherwise it normally would slip through unless there's a particular pattern to it. And of course that causes the phones to ring and ties up equipment, ties up people's time, makes a mess of it. And the end result is that customers who are trying to call this business are getting a busy signal, or ring no answer, or nobody's taking their call, or they end up in voicemail. They just become very frustrated, and of course this business is just not getting what the service that they had anticipated. So working with TransNexus, we've come up with an innovative solution, and one of the things that we've come up with is to integrate a cloud-based analytics platform that you're going to learn about today via SIP to the SBC, and this is going to send over a SIP invite and get one of 3 responses back from that invite as to what to do with that call. And we'll step through this in a little bit more detail here in a couple of slides, explaining how this all works. So what about TDM customers? And this can still be implemented in, matter of fact, our case studies, some of them will be TDM based. They're also going to have a situation where they're actually using T1s or E1 PSTN trunking. Again, still a TDOS attack can flood that infrastructure, but it's going to land instead on a session border control. It's going to land on a media gateway, and that gateway will still use SIP to communicate to the cloud-based analytics platform, resulting in one of 3 responses, which then will be used to decide where to direct the traffic. Either reject it, or screen it, or pass it along to the users. So this is in a nutshell the architecture that we're going to be talking about today. So how's this done? We mentioned that the SIP invite is sent over, and of course there's a picture of what a SIP invite looks like. Thanks to the folks from TransNexus that shared this invite. And there are 3 SIP response codes that come back from this invite from the analytics platform. And we'll be talking about these. So 503 response code means that, I know in SIP parlance it says service is unavailable. Well, what this is telling the SBC or the gateway though, is that the call is actually good, and what you should do is proceed to the next route on to your destination. Or a 603, which is a SIP decline. And the call is bad, and then the gateway or the session border controller should just drop the call. Or a 302, which is in SIP parlance is moved temporarily, and this is a scenario where the call is suspect, and we're going to reroute it to a screening application, which you'll learn about here.
Alan, I think the good news is stopping TDOS attacks with the platform that you just described, this cloud-based analytics. We can definitely go through the slides, and you've got them here, but I think the key thing is it's really pretty simple, and I could have told the story without the slides. But since you've got them here, let me walk through them. So really there are 5 tools that we provide for our customers to help them block TDOS attacks. And we'll go through each one of these. It's blacklisting, it's invalid calling numbers to identify bad calls, high risk calling numbers to identify those, and more advanced analysis based on calling numbers that are known to be bad, and our own real-time analytics of the traffic. And I guess what's simple, it can be a very global solution. It's kind of a plug and play, and that's works for some customers, or it can be very specific for special situations, very granular in how it can be configured. So if you could go to the next slide, and I'll kind of walk through these different tools. And the first one is highly flexible blacklisting. I mean, blacklisting, that's pretty simple. It's been around forever, but we've learned over 20 years, I think there are a lot of different ways to blacklist and whitelist calls. And I think we've got every possible feature of ways to do that built into our software. And one thing that's really nice about our approach is it's really easy to use. So our platform, as you point out through that SIP API and those messages, it's effectively a network element. but it's not in the call path. And what's great now, actually a customer service rep could go in and blacklist a call. You don't have to call the knock and say, you know, we need to blacklist this calling number. We've got the tools that are easy to use, that are very flexible, that give really anybody in the organization access to address immediately for a customer a TDOS attack. And that would be for a service provider. But if it's for an enterprise, it's an easy to use solution. You don't need to be a telecom engineer to be able to take advantage of the different ways to blacklist calling numbers and or a calling call number combination to protect your network. So that's number one. That's the simplest tool. It's easy to understand. It takes about 10 minutes of training for people to understand. And if you could advance to the next one, another really simple tool. I mean, this is just a click. It's on or off, but it works great for our customers. It's our own database of high-risk numbers. We're constantly adding to this list and monitoring, updating from the LURG, our own honeypots, FCC complaint lists of either invalid numbers or high-risk numbers. And this is a very good filter for blocking robocalls, but also calls that could be malformed and often used for a TDOS attack. So again, very simple, in place, and effective for stopping robocalls, our own database of known high-risk telephone numbers. And a point I want to put at the bottom that, you know, our customers like is all of these features are not necessarily global. You could specify the use of this Shield database on a per subscriber basis. So a lot of granularity in terms of how you want to apply these tools. So that's our Shield database of known bad numbers. And if you could move to the next slide, to get a little more advanced is to be able to use the reputation service that we're tapped into. And this is analysis from industry partners from a wide source of information sources to identify dynamically, because this is changing, calling numbers that have a bad reputation. And great for robocalls, great for TDOS attacks, you know, telephone numbers that are showing up in different places, calling numbers that are being alarmed as, you know, being used inappropriately. And so we get these scores for every call in real time. And if it's completely configurable, you can set the reputation score of, you know, do you want to block calls if the calling number has a bad reputation, and take advantage of it that way. So we have our reputations service as part of this filtering mechanism for bad calls. And the last is our SIP analytics. And if you could just advance to the next slide. One thing we do, I think is really unique, is we are keeping track of every call by calling number, could be by trunk group or IP address in addition. And we are learning over a 12-week period, what's the normal calling pattern from that calling number at this time of the week. And those real-time analytics are great for learning, you know, here is some odd behavior right now from this calling number, so we can take action. And all of these tools have the same opportunity to take the same action that of either blocking or diverting the call. And the SIP analytics are very effective for identifying rogue calling numbers that are pumping traffic very, very quickly and stopping an attack. So 5 different tools. Some are simple and easy to use, and maybe all you need. Blacklisting might do it for some cases we've had. It's that simple, but if you have more complicated cases, we've got multiple tools here you can layer on that can stop a sophisticated attack. And if you could advance to the next slide, I'll just point out, you know, what do you do if you're getting hit by attack? What's the experience? And we give you choices of how you want to respond. So first, just report only. And, you know, you don't want to block any calls. You don't want to interrupt the calling parties for whatever reason. You can start that way, just report only. But quickly, it's easy to block calls. And so you're under attack, you can just block calls. If you know the source, especially, you can block calls from a specific source or a calling number. Or maybe you want to route that call to voicemail. You never want to block a call. You want to make sure you've got some record of it. And more commonly for TDOS, which really works well for our customers, is we route calls to a CAPTCHA gateway. And what a CAPTCHA gateway is, it just plays a greeting and it filters out machine-generated calls. And you might want to click on the audio sample. I don't know if that's connected or not, but if
Hello, your call is being connected. As a security precaution, please enter the following 2-digit code, 98. Please hold. Now connecting.
So that's a great way under a heavy attack to just filter out all the machine generated calls and still let callers get through. So very effective. You know, you're in an emergency room. You've got to answer the telephone call, but you're getting overloaded, like you pointed out in your slide earlier. You've got to let them through. This will screen out, filter out all the bogus telephone calls, and you'll just get the live callers. And then the last thing, what our customers, some of them have take advantage of, is they use the CNAM display. We can replace the caller name ID with the spam message to give some kind of indication if they're not using these other tools to block or filter rogue calls. So anyway, those are the options we give you. You know, if you're under an attack, how do you handle it based on, you know, your use case, your customers, the parties that need to be called. You have different ways to create a response to handle that. Just wanted to, I was going to talk about some future trends, and that's okay. Before we get to the case study, let me just talk about a couple of future trends. So first of all, as you pointed out earlier, I mean, the threats for enterprises are increasing. This is, we didn't come across this 3 years ago. And I know TDOS, you talked about an attack on a 911 center a few years ago, and it's always been around, but I guess what's important, it's accelerating for enterprises. That's the threat that we see. And you know, it's really interesting. We talk to people like, I never get by fraud. Nobody ever gets by fraud. It'll never happen to me. But when it happens, I tell you, enterprises, they can be shut down. Their business, they depend on inbound calls for their business. And when a TDOS attack occurs, it totally destroys their business. They're desperate. What's great about this cloud solution, we can protect somebody's network immediately. Literally, it's just an hour to provision this tool and to stop the TDOS attack. You know, if they have one of your SBCs, it's very quick in terms of implementing the solution. And what's wonderful is they are so grateful. You've saved them from a disaster. And so that's just part of this cloud tool that you can react so quickly when you have a TDOS attack for a solution. One thing I'll add is, you've mentioned this is, you know, it's for enterprises. This is really a new opportunity for service providers, because we're finding enterprises that come to us, their service providers can't help them. And this seems to us, it should be a basic tool that every service provider should have to be able to help their customers. And it's the service provider, that's a great place to really absorb an attack before it even gets to the customers. And I think you're going to see more service providers take advantage of these kind of tools to protect their customers, because that's what customers are expecting. And the last point I just want to put out about future trends, it's this slide, which is shaken call authentication. If you hadn't heard about it, it really is a game changer for telephony denial of service attacks. And what this shaken call authentication is every calling number is going to be digitally signed. Every call has a fingerprint on it that identifies the source of the call. So it's really easy, fast trace back for law enforcement. And if you can get to the bad guys, then you can put an end to this pretty quickly forever. And as you point out up front, it's easy to remain anonymous and just send all this, you know, dangerous traffic, but shaken should fix that. So anyway, those are the kind of future trends we see, you know, more threats to enterprises, opportunity for service providers. Shaken will really address this once and for all, we believe, but that's another webinar. And let me stop there. I want to hand it over to Alec, because he's worked with, you know, with folks at TelcoBridges and a lot of customers and just heard their stories. And it's it's interesting to hear them share their stories. So Alec, I'll let you take over from there.
Yeah. So I'm going to talk about a couple case studies that we've seen where there were customers that came to us, and in all three of these cases, it's the enterprise coming directly to us who's got an issue with it's a denial of service attack of a different type. And so this first case study is about a manufacturing business in Texas. So they went to bed every night, came in the morning, and they had more than 200 voicemails on their phone system every morning when they came in. And, you know, of course, one or two of those are real customers. And to go through that list of voicemails to find those few customers was a daunting task. For whatever reason, they were just getting flooded with phone calls, leaving voicemails, random, you know, people trying to sell stuff, all sorts of different stuff. Their number got on a list somehow, and it was crippling them. They could barely get back to their customers. So the solution was just so simple. We deployed with integrating with TelcoBridges SBC, and we deployed our CAPTCHA gateway, so that the CAPTCHA gateway call comes into their network. If it's suspected to be a bad call, it routes up to the CAPTCHA gateway, plays that message that you guys heard a moment ago, and verifies that it's a human. Now, that's not doing that to every call. It's just doing to the suspect calls. And what that really, the big advantage of doing that is, I mean, we catch every robocall, absolutely. And the one or two legitimate customers that do get caught up in kind of as a false positive, just get through the CAPTCHA gateway without any issues. So their voicemails got 1 or 2 in the morning with just those real customers, which is a big improvement for them. Another case study, our second case study, is a travel business. So this particular company, they sold, they're kind of similar to Expedia, kind of selling flights and hotels on the internet. And all these companies, they're all kind of selling the same hotel room. So they're really the big thing for them is price. They're trying to offer the lowest price. It's a very price sensitive area. And one of their competitors was calling them repetitively. Knowing that what would do is cause them to have to hire more agents to answer the phone. More agents means they have to charge more for the same hotel as the competitor, and then the competitor can win the business. So this was kind of an interesting one that we were able to stop. And so what we did is we deployed our software. SIP Analytics. It was a standard SIP switch. It wasn't TelcoBridges equipment. Integrated with that, and using SIP Analytics, we can identify, we got a big influx in traffic. This is where it's that suspect traffic. And it was very easy to tell. And they've been really cut back on those robocalls, and their agents are able to answer legitimate customers, and hold times are much lower than they used to be. And then the final case study, I think this is one of the most recent of the three, as an auto dealer in Florida. So they have, they sell cars. They actually ran a phone system for a couple different dealerships that were all kind of partnered together. And they were just getting flooded with calls. It was around the same time every day, just a flood of traffic. And the operators, the humans, as well as the PRI line that they had from their carrier, one of the two would give up, and they have big issues. So a lot of times the operator just couldn't handle the phone calls anymore. But a few times they actually filled up the PRI line, and they couldn't. 23 channels is all you have. So for this particular customer, we had a really nice solution where we integrated with the TelcoBridges equipment. So they had, as I mentioned a moment ago, they had PRI from their carrier to their PBX, and our partner TelcoBridges sent them a TelcoBridges gateway that dropped in between the carrier and their PBX. Their PBX and the carrier don't even know that it's there. It's just a transient device, and that sends every call up into our platform to do the analysis to identify, is this a bad call, before passing it over.
I think we got an animation here to explain how that all worked.
Yeah. And the beauty of this solution was it was so simple for them to deploy. You just drop the gateway in there, literally unplug that PRI line, plug it in to the gateway, and run a new one to the PBX, sitting in the same rack. And it's stopping all their calls. Very, very effective. And because this analysis is all done in real time, that channel utilization is only up for milliseconds. Our whole analysis happens in a few milliseconds, and then the channel is freed up and they're ready to have another call. So both their operator that answers the phone, as well as that PRI of limited 23 channels, are both working great right now.
Yeah, and I think, Alec, the beauty of this solution was the fact that for the enterprise, it was unplug, plug this gateway in, and the gateway, of course, uses the cloud to do the analytics and the CAPTCHA gateway. So it minimized the amount of equipment that needed to be on-prem, and made it very easy for them, because this is just pass-through, right? From their perspective, it's T1 in, T1 out. And
Exactly.
They didn't have to do anything with their PBX. They didn't have to do any reprogramming of the PBX. There was no modification to this, and it just made it very, very simple.
Absolutely, and I think that's a big thing that we do see that's a little different with, the enterprise type of deployments. Carriers, they're familiar with their switches, they're familiar with their SBCs, they know that stuff in and out. But a lot of enterprises, the guys who run the telephone systems are the guys who run the IT systems. The telephone is just a small portion of what they're responsible for. And in general, the internet, that's where you're so focused on your threat detection, prevention. But so, you come in with this issue on the telephone system, and this just, the PBX is just not something that they're familiar with. It's not something that they're able to go in there and make a lot of configuration changes from quickly and easily. But so by dropping in a gateway that literally does not require them to touch the PBX is really just, it just really expedites the process.
And another piece of this too, I wanted to add too is, even though in this particular example, this auto dealership, we did, the auto dealership purchased this equipment and the service, there's no reason the service provider couldn't come in and said, you know what, we have this solution, and they could have dropped this in and either rented it or leased it to them or sold it to them as a service for the car dealership. It very easily could have been offered by their service provider. In this particular case, the service provider didn't want to have anything to do with it, which is unfortunate, and left the poor auto dealership to fend for themselves. So, yeah, it's an interesting quandary, but I think it's an opportunity for the service providers to pick this up and run with it.
Yeah, absolutely. I mean, every time we hear from some enterprise who's got a TDOS solution, the sentence always is identical. I contacted my carrier. They said they can't help me. Yeah. Can you help? I mean, it's always that. So I do think that carriers need to. I think there is a solution. Clearly, it can be deployed at the enterprise, but that requires every enterprise to deploy something. Sure. Versus deploying it at the carrier, you can protect every enterprise behind that equipment immediately, which is obviously a much quicker solution, because these things come up, quickly. Sometimes, you call someone in, they don't issue a refund. They ask for a refund, and they decide to denial of service attack you the next day, and you had no idea. So it's kind of hard to wait until there's an attack. That's the worst time to try and deploy something.
Yep. Awesome. Well, great. Thanks for those 3 case studies. They were really interesting, and I think give some good insight. So we wanted to wrap up with a little bit on the various portfolios. This is I see some questions trickling in here about the the pieces and parts here. The TelcoBridges brings to the puzzle our signaling immediate gateways. The TMG 800 is for T1E1s. The TMG 3200 is higher scale for like DS3s. And of course, a very high scale TMG 7800 for much larger, probably larger than the solution. Maybe centralized in a service provider could deliver some service like this. But that's the core of the portfolio from the gateway side. Our SBC portfolio includes, for this particular solution, Pro SBC. It's our virtualized session border controller software that can sit in a VMware cloud or can sit on a standalone bare metal server. Can be in the cloud, could be completely hosted, or again be inside the data center of the enterprise. And along with that, some support and professional services that are optional for that particular platform. So I know before we wrap up here, maybe Jim, you want to just talk real quick about some of the offerings that are available from TransNexus?
Yeah, Alan, thanks for the opportunity just to share that. So as I mentioned kind of in the opening, our focus is really an intelligent routing platform for service provider customers, but also enterprise customers. Mm-hmm. And it's used often for least cost routing and also for toll fraud. But that same platform has policies that are great for managing inbound, like we've talked about for everything in this call for robocalls and TDOS attacks. And we offer the solutions in the cloud, like we've discussed in this presentation, but also on-premise, so customers have a choice. And for service providers, all the features also include a complete suite of applications for rating, mediating, and reporting call detail records. So it's a complete solution for managing SIP trunking services.
Yep. I also want to note too, in our past 21 webinars, we did another session with TransNexus on battling robocallers, and explains in great detail how the STIR Shaken platform works and what we've done with them and integrating that and of course it relates, obviously you heard from today's topic, directly in providing service providers a method to validate caller ID. So our video library will be a great place to see all that at freesbc.com/video-library. So with that, wanted to kind of wrap up with where to learn more. We've got a couple of options here. We keep all our frequently asked questions, so all your questions that you shoot to us, we try very hard after the event to put them on our forums, .freesbc.com, and again, we have other content on our YouTube channel, youtube.com/TelcoBridges. And of course, the various websites, prosbc.com and transnexus.com are a great place to go for more information. We also set up a landing page, which I'll tell you about here real quick, which is at www.2.telcobridges.com/TDOS, capital TDOS, help, lowercase help. And that's a place that you can reach out to us to get more information on this particular TDOS solution. So let's get to the Q&A here. I'm just looking, there's a handful of open questions. Looks like there was a bunch of simple questions that were answered online. I'm going to just circle back, and just for the recording, I'm going to go circle back to some of the answered questions. I know you guys have shot answers on the in the portal here, but maybe Jim, could you answer the question? Is the TransNexus, is your service a hardware or a software platform? And then if it's software, what platforms do you offer it on?
So it's software. It works great in a virtual environment. It's software in the cloud that we've talked about in this webinar, but it's also software that can run on premise.
Sure.
Just needs CentOS operating system for on premise. Okay,
great. And then the question, does the TransNexus platform work with FreeSBC? And the answer is, unfortunately, the free version of FreeSBC does not support that redirect process that we showed earlier. That's only supported on the Pro SBC version of the product. So sort of answers that question. So we got a question here from John. He's a EMS company, serves 5 states in secondary PSAPs. They're concerned about blocking legit calls. I don't know, maybe you got some thoughts maybe on that, Jim?
Well, I think that's the case where the CAPTCHA gateway really is a great way to filter out the bogus calls, the machine-generated calls, and still lets a human get through.
Yep, okay. So let's see. Jason asks, there's centralized SIP trunks from their LAC for their Avaya platform, and looking at a project to implement Teams. Can we leverage the hosted solution in this scenario? Actually, it doesn't matter downstream what PBX there is downstream. If we do it at the SIP trunk up front, all the screening happens before the PBX or UC platform or Teams or Avaya or anybody else sees the call. So this really is universal. It's completely transparent to the application that's downstream. So in a TDM world, Mark asked a question for TDM. The gateway not connected to the internet, and then of course the answer is yes, the gateway does need to be connected somehow or another to the cloud IP platform. Does it need to be connected to the internet? Well, some people would choose that, but it could be an MPLS circuit, or it could be a private circuit, it could be a VPN circuit, I guess, over to your platform. But you'd have to make those arrangements with you, right, Jim?
I tell you, I think that's an on-premise solution.
Okay.
Where it would make sense, and if they don't have, that would probably be the way to go.
Got it. Okay. And so a question about, is the CRTC customer complaints, do they work your way into your database?
We don't actively pull from those. So we pull from the FCC. There's an API. We can get that information automatically. I'm not aware of the CRTC having a similar kind of API that we could use. If there is, we'll absolutely support it. We're just not aware of it.
Sure. Okay. And then, of course, how many T1s will the gateway handle? And of course, and one of the things with that architecture we showed you in that slide is there's a T1 in and a T1 out. So in that particular situation. The customer only had one PRI, so it's one T1. So the gateway had to have two T1s to be able to use that architecture. So a 16 span TMG 800 would support 8 spans going in pass-through mode, and we can build out as many either gateways or move to the 3200 platform, move up the DS3s. I mean, the sky's the limit. So I guess the answer is I don't see any practical limit other than just the amount of space you have available to put all the equipment. Let's see, moving on then, let's see. So John asked sort of a follow-up question: when it implement only for non-emergency call centers, could they enable different filtering per DID or even within DID ranges? And I guess yes, the answer is we could very easily do that with the routing tables in the SBC, or I think probably even with your tables within ClearIP, you could do that too.
Absolutely.
Yep. Let's see, a couple open questions here. So for service providers, would you recommend implementing this per customer or as a whole? So maybe you want to take a stab at that first, Jim?
Yeah, and you've got choices as a service provider. It could be a global, but I think really the beauty is you could implement this individually for each customer, have different policies for each customer, be able to charge for the customers that you offer the service to. So you've got complete flexibility of how that could be managed. And the cloud solution has an API, so automated provisioning of those policies would be easy for a service provider. And you could even give your customers access through a protected web interface to implement their own policies. So a lot of flexibilities, a lot of choices in terms of service creation possibilities.
Yep. Jason asks, he says, we're a cloud-based service provider, offer multiple services like SIP trunking. They register phones to PBXs, as a wholesale with multiple wholesale carriers. Is it possible? And if I'm going to move back to that slide here real quick. Matter of fact, in this slide here, this particular customer here, this line here, this is the point of demarcation. This line could be way over here. You could very easily host all of this. Hosted PBX. ClearIP could be hosted, the SBC or gateways could be hosted. This whole thing could be in a hosted environment, and you could offer it to your customers. And as Jim noted, this as a service has genuine value. These businesses, and like I mentioned, a furniture manufacturer came to us and told us did the arithmetic on their call center, and it was easily demonstratable from a financial standpoint that there's value in offering a service like this to be able to protect them from attack. So let's see. Oh yeah, here's a tough one. So Mike asks, some of the spammers are using real customer numbers to spoof their calls, right? Neighbor spoofing. And you can't, of course, blacklist their number. How do you determine that a number is suspect if it's a neighbor spoofed number? So you want to take a crack at that?
Sure. It's tough. Spoofing is tough. I mean, neighbor spoofing specifically, we have a great blacklist feature for service providers where they receive external calls using their own numbers for neighbor spoofing. That's a very simple block. But this is really the example where Shaken will put an end to this, where you can no longer spoof calls. And that's coming. When you'll be able to verify every call coming in, look at the digital signature and understand, this is the real customer calling based on their signature, or that call is not validated. I don't know about that call. It could be spoofed. So this is on the horizon, and I think you're going to see that. We've deployed that for our customers now, and you're going to see that roll out all in 2020, and it should be penetration of the market is going to accelerate, and that's the ultimate solution for stopping these attacks, is having a valid calling number you can make a decision on.
Right. And also too, I think it's important to understand that CAPTCHA gateway will nip this scenario in the bud too, right? The CAPTCHA gateway will catch these calls because there's no human behind making the call. they'll get caught at the CAPTCHA gateway. So that's, you know, you're not blacklisting somebody, you're just giving them a manual step that they have to go through if you're under an attack. And I also think there's also the scenario where, you know, if a particular number becomes a persistent pest, that they get escalated to the CAPTCHA gateway, and if they continue to hammer the CAPTCHA gateway, then you'd eventually could blacklist them, right? So it's like steps or rungs on a ladder where you're going to move them from clear to blocking them.
Absolutely. Yeah. Thank you for that clarification, Alan.
Yep. So yeah, John asked a question about redundancy. So you know, how's the platform handle failures? And of course, for our media gateways and session border controllers, there is 1+1 configurations that allow them to fail over. You know, a T1 could have an alternate route and a backup route to an alternate physical connection. So yeah, what about the connection out to the Clear IP platform?
So Alec, I don't know if you want to describe a little bit about the Clear IP architecture and about the resilience that it has.
Yeah, so we have two deployments, an on-premise system and a cloud deployment. The Clear IP is the cloud deployment, and that system is spread across 4 data centers. So we have 4 data centers, and each one of them has an active server in it. So actually have multiple active servers in it. So even if we lose 1, 2 data centers, it doesn't in any way affect our ability to respond to your requests for services. We've been operating that cloud product for, a little over 4 years. And in that time, we've never had any outage of any kind on our processing of requests for customers. We also have an on-premises product, and in that deployment model, you run multiple servers. Each one of them is a copy. They're all the same thing. And so that you can lose one, you can run multiple for both scale as well as high availability purposes.
Great. Well, there are lots of interesting questions here, and looks like we're at almost the top of the hour here, so we're running out of time. So I just want to wrap up with a few closing comments. First, I want to thank Jim and Alec. You guys have been super helpful in putting this together and sharing your expertise. I think there's a lot of good content here. My apologies for screwing the slides up. We'll fix those in post and share the recording. Will be all cleaned up. As noted in the opening housekeeping, you will be receiving an email within the next day with the links to the slides, including a corrected recording of today's event. Please feel free to share that with others in the network that might find it helpful. And Jim and Alec, once again, thank you. And that's it from here. Thanks for listening. I hope you found this content useful. And don't forget to share this with any other your coworkers or others that might be interested. Also, don't forget to click on subscribe, and there's links below.